Hello everyone, I am Dr. Godandaraman. In this section we are going to discuss with convolution theorem problem. See the problem, find L inverse of s square by s square plus a square into s square plus b square using convolution theorem. So convolution theorem is nothing but convolution theorem L inverse of f of s and g of s, then we should write the form of L inverse of f of s star L inverse of g of s. For this function it's coming with f of t star g of t. Now how to solve this f of t star g of t? The star is nothing but convolution theorem symbol. Therefore f of t star g of t should write the form of 0 to t, f of t to replace f of u, g of t minus u into du. So this is a convolution theorem. So now, what is the use of the convolution theorem? Normally L inverse of a plus b, L inverse of, suppose L inverse of function a some plus b, it's possible for L inverse of a plus L inverse of b. L inverse of a minus b also possible, L inverse of a minus L inverse of b, to solve this two condition using some property or direct important result to solve this problem. It's a possible. But if L inverse of ab, when it's a product or divide L inverse of a, L inverse of b, L inverse of a by L inverse of b, these two not possible. So only we can use the partial fraction. We can use the partial fraction and convolution theorem. Convolution theorem. These two methods to solve using when is given a product or division wise. This is the only reason. Okay, now how to solve the given problem? How to solve the given problem is L inverse of s square by s square plus a square, s square plus b square. Now to consider this L inverse of s by s square plus a square, then s by s square plus b square. I just rewritten the given question, s square s into s, then denominators just rewritten, nothing different, rewritten. Because of why the reason? See, compared to this L inverse of f of s, g of s. So this is a f of s, this is a g of s. Therefore now should write L inverse of, when this is a form, should write L inverse of s by s square plus a square star L inverse of s by s square plus b square. Now I am just splitting with, this is a form, and then taking this L inverse for the important result. So what is the L inverse? L inverse of s by s square plus a square is nothing but cos at star cos bt. This is the important result. Then after that f of t star g of t. See here, when f of t g of t, then change this, because I want to remove this convolution theorem symbol. How to remove? Taking integration, then where t to replace u, where another t replace t minus u, to consider any one, the first term f of t, second term g of t, or second term f of t, first term g of t. Two function, that's all. We can take anything. Therefore this star how to remove? Using integration. So integration of 0 to t. For the first one, this t should change with u, cos a u. The next one, this t change with cos b t minus u into du. This is a changes. So now the symbol, convolution theorem symbol removed. Now 0 to t cos au cos bt minus bu into du. Now should integrate this, but two function is difficult to integration. Therefore, the formula cos a cos b is nothing but 1 by 2 cos a plus b plus cos a minus b. Use this formula. Therefore, integral 0 to t, this is a cos a, the whole term cos b. Therefore, cos a plus b 1 by 2, a plus b means au plus bt minus bu, a plus b plus cos a minus b, au minus bt minus of minus plus bu into du. Now I am taking 1 by 2 common out. Therefore, here 0 to t, cos a, taking u is a variable. Therefore, a minus b into u plus bt. Then plus cos a plus b into u minus bt. Then du. So generally, what is the integration? The integration of cos ax dx equal to sin ax by a. Integral cos ax plus b is nothing but sin ax plus b by a. Why only a? Because the variable coefficient, in variable the front value coefficient, only should write denominator. Therefore, see here, therefore, this is a form. Which form? 1 by 2. When I am integrating, here this is a variable and this whole terms are constant. Now when I am integrating, sin a minus b into u plus bt by a minus b, this is a constant, plus sin a plus b into u minus bt by a plus b, 0 to t. Substitute upper limit minus of lower limit. Where to substitute? U. When I am substituting upper limit, 1 by 2 sin a minus b into t plus bt by a minus b plus sin a plus b into t minus bt by a plus b. This is the upper limit. Then minus of the lower limit, minus sin a minus b into 0 plus bt by a minus b minus sin a plus b into 0 minus bt by a plus b. This is a plus, means I am taking common minus. Therefore, now simplify this 1 by 2. This term sin at minus bt plus bt by a minus b plus sin at plus bt minus bt. Just multiply inside this bracket, this is a plus b, and then minus sin bt by a minus b minus sin minus bt by a plus b. When I am cancel this two term, bt cancel, this bt cancel. So sin a minus b into bt. So therefore, this is a term 1 by 2 sin at by a minus b plus sin at by a plus b minus sin bt by a minus b minus sin of minus sin plus sin of minus x plus So sin bt by a plus b. So now to take this LCM denominator, so 1 by 2 when I am taking LCM, a minus b, a plus b. So a minus b, a plus b I am taking LCM. Therefore here the first term a plus b into sin at, then second term a minus b into sin at, this term a plus b into sin bt, and this term a minus b into sin bt. So when we multiply each and every term, 1 by 2 a sin at plus b sin at, the next term a sin at minus b sin at minus a sin bt minus b sin bt, next term a sin bt minus b sin bt by a square minus b square. Now any common term, see a sin at, a sin at, here b sin at cancel, and minus a sin bt plus sin bt cancel. Therefore 1 by 2 2a sin at minus 2b sin bt by a square minus b square. Now I am taking 2 common out. Therefore 1 by 2 into 2 whenever I am taking a sin at minus b sin bt by a square minus b square to cancel this 2 2. Therefore a sin at minus b sin bt by a square minus b square. Thank you.